Welcome to today's online physics class. Today we are looking at this topic that I titled X-rays. Before I go into the topic, let me quickly recap those things that I have taught you in the previous lesson. I told about photoelectric effects, and I said photoelectric effect is a process whereby electrons are being emitted from the surface of a metal when light of appropriate frequency strike the metal surface. And that simply means it is not light of all frequencies that can cause electron to be emitted from a surface of a metal. It is not only by photoemission that electrons can be emitted from the surface of a metal. There are some other processes by which electrons can be emitted from a metallic surface. And one of them is what we refer to as a thermionic emission. This has to do with emission of electron when a metal is heated directly. When you heat a metal directly and electrons are being emitted, that process is referred to as a thermionic emission. Other processes by which electrons can be emitted from a metal surface are, we have one, we talk about feed emission, and we also have a secondary emission. These are the different ways by which electrons can be emitted from the metal surface. Now, I want you to take note of this about photoemission. It has to do with conversion of energy. Energy of the incident photon is being converted to energy of the electron emitted. That means the energy of incident photon has been converted to kinetic energy of the emitted electrons. Today we are looking at X-rays. When electrons strike a metal surface, what happens? In the case of photoemission, when photons strike a metal surface, we know that electrons will be emitted if the frequency of the photon is appropriate. But now we are looking at a situation that when electrons strike a metal surface, what happens? And what happens is that the energy of this electron, the kinetic energy of the electron, will be converted to a photon energy. The photon produced in this process is what we refer to as X-rays. So X-rays are electromagnetic waves of short wavelength and high frequency. They are produced when fast-moving energetic electron accelerated at high potential strike a metallic surface. Remember what I said? I said they are produced when fast-moving energetic electron at high potential strike a metallic surface. It is then X-rays will be produced. Now, let's look at the production of X-rays. When current flows through a filament, electrons are emitted from the surface of this filament. These electrons are accelerated at a very high voltage and low pressure in an X-ray tube. And as a result of this, the electrons will strike the metallic targets, and this will cause part of the energy of these electrons to be absorbed by the target, and remaining energy will be converted to X-rays. So that is how X-rays are being produced. Now let's talk about energy transformation in the production of X-rays. Now, as we know that for the production of X-rays, a filament must be heated by electric current. That means the energy transformation in X-rays start from electrical energy. This electrical energy will be converted to heat or thermal energy in the filament, and as a result of this, a thermal energy will be converted to kinetic energy of the emitted electron from the hot filament. This kinetic energy will also be converted to electromagnetic radiation. And lastly, electromagnetic radiation will be converted to thermal energy or heat energy. I want to talk about hardness of X-rays. By hardness of X-rays, what do we mean? Hardness of X-rays simply refers to the electric power of X-rays. Based on the hardness of X-rays, we have two types of X-rays. We have the first one that is referred to as hard X-rays. Hard X-rays are of short wavelength, high penetrating power, and they are being produced by high voltage. They have this characteristics of having short wavelength, they have high penetrating power, and they are being produced by high voltage. While soft X-rays, they have long wavelength, low penetrating power, and they are being produced by low voltage. When you look at these two types of X-rays, we can easily differentiate between hard X-rays and soft X-rays. Let's look at properties of X-rays. There are various properties of X-rays. 1. X-rays are electromagnetic in nature. 2. X-rays cannot be deflected by either electric field or magnetic field. So electric field cannot deflect X-ray. The same thing, magnetic field, it cannot deflect X-rays. The third property is that X-rays are of short wavelength. X-rays are of short wavelength. Fourth, they have high penetrating power. They have high penetrating power. X-rays they have no charge. Now, when they make contact with materials, they ionize them. When X-rays make contact with material, they ionize them. They cause fluorescence in materials such as rock salt, calcium compound, or uranium glass. Now, X-rays can be reflected, they can be refracted, and they can also be diffracted. X-ray can be reflected, refracted, and diffracted. They affect photographic plates. They affect photographic plates and paper, causing them to be fogged. Let's talk about the general uses of X-rays. Now, we have use of X-rays in medicine, we have use of X-rays in industry, in transportation, in agriculture. So there are various areas where we can use X-rays. But let me just talk about the general uses of X-rays. 1, we have X-rays are used to detect hidden cracks in materials. 2, X-rays are used to detect pressure to work of art. X-rays are used to show broken bones, in human body. X-rays are used in crystallography, that is to study the internal structure of a crystal. X-rays are used in diagnosis of ulcer. In agriculture, X-rays are used in killing germs. X-rays are also used in radiotherapy, that is to treat sickness. In industries, X-rays are used to detect faults in metal, casting, and welding. In transportation, X-rays are used to detect contraband goods in bags and luggages. These are the various uses of X-rays. Now, I will talk about the hazard of X-rays when you have overexposure to X-rays. What are the different hazards or dangers that somebody can incur when you are overexposed to X-rays? Number 1, genetic mutations. Overexposure to X-rays can cause genetic mutation. Number 2 is skin-borne or skin tan. And we also have, it can cause leukemia, it can cause tissue damage, it can cause cataracts and baldness. These are the different hazards that someone can get when overexposed to X-rays. Now, since we know that X-rays are so hazardous, what are the safety precautions that must be taken when using or working with X-rays. Number one, the use of dosimeter for regular checkup to know the amount of the dosage you have in your body. Number two is the wearing of lead coat. So we put on lead coat, and lastly, regular and periodic medical checkup. So these are the things that I want us to know about X-rays. In our next class, I will talk about wave particle duality. Thank you.